In the last part of the question, we're going to use a result that we found in C, which I've written here, to check the values of py and ty that we found in part A and part B. So the first thing we're going to do is find the probability of winning from node y, and the second thing we're going to do is find the average length of the game starting on node y. Now what this equation tells us is the probability of being on each of the 4 nodes after n steps in the game if we started on node y. So you can see here, here's our starting point on node y. Each row corresponds to a different node. We have x, y, w, and l. So let's start with the first part of the question. If we're interested in the probability of winning from node y, then we're going to look at the third row, because the third row corresponds to the probability of being on node w. So the probability of winning from node y is equal to 7 over 12 times 1, plus 5 over 12 times 0, plus 2 over 15.7 to the power of n times negative 4, minus 1 over 20.2 to the power of n times 1. And I'm just going to write this more simply. And now if we're interested in the probability of eventually winning from node y, we're going to look at this equation as n approaches infinity. So in other words, eventually, after many steps in the game, what's the probability of ending up on node w, or the probability of winning? Now, as n approaches infinity, this term, 0.7 to the power of n, is going to approach 0. And you can check this by subbing in consecutively larger numbers into n, and you'll see that it does get smaller. So this full term approaches 0, because 0 times this term is going to be 0. And similarly, this term approaches 0. So what we're left with is py is equal to 7 over 12. So in other words, the probability of winning from node y is 7 over 12. And this corresponds to the thing we found earlier in part A. Now we're going to look at the average length of the game. Now in this case, we're going to use the 2 top rows of the equation because we're interested in how long you stay on node x and node y. Because if you're still on node x or node y, you're still in the game. If you're on node w or node l, the game is ended. So let's look at xn, the probability of being on node x after n steps if you started on y. 7 over 12 times 0 plus 5 over 12 times 0 is 0, so we're going to leave those out. Then we have 2 over 15.7 to the power of n times 3, minus 1 over 20.2 to the power of n times 8. Now I'm just going to simplify this a bit. And again, just simplifying the fractions. So what this tells us is the probability of being on node x after n steps. Now I'm going to do the same thing with yn. So again, 7 over 12 times 0 plus 5 over 12 times 0 is 0, so we leave that out. Then we have 2 over 15.7 to the power of n times 3, minus 1 over 20 times 0.2 to the power of n times negative 12. Simplify this. And again, just simplify the fractions once more. And now because we're interested in the average length of the game, we're interested in basically how long you stay on node x and node y. So we're going to add these two up. So I'm just going to write it this way just so you can see the adding. So I'm just rewriting xn here and rewriting yn. Summing these up, we get 4 over 5.7 to the power of n minus 1 over 5, plus 1 over 5, sorry, times 0.2 to the power of n. Now to find the length of the game, we want to take the limit of the sum. So starting at n equals 0, we're going to sum up until n equals infinity. So instead of taking the limit of the equation as n approaches infinity, we're actually taking the sum as n approaches infinity. So you do this slightly differently. And we're interested in the sum because we're interested in the length of the game. So now to calculate the sum, what you do is you keep this there. Then the sum of this as n approaches infinity is going to be 1 over 1 minus 0.7. So you can see the 0.7 goes down there. And the same thing with this fraction here. It's going to be 1 over 1 minus 0.2. And the 0.2 goes to the bottom. Now if you calculate this, you end up with 35 over 12. And this tells us that the average length of the game is 35 over 12 moves. And this corresponds with what we found in part B of the question.